Hello, Algebra 1B, and welcome to this lesson on solving by elimination. I want to get you guys really hyped about this because this is like one of my favorite lessons in algebra. I think it's very fun. So I'm sorry I'm not there in person to hype you up, but get excited because I really like this. So again, we're looking at systems. At this point in these lessons, you know how to solve systems two different ways. You know how to solve them by graphing. Graphing is where you graph your two equations on a graph and you look for that point where they intersect, and that would be your solution point. The second way we've learned is solving by substitution. If you're going to use substitution, you need to have an equation that says like x equals something or y equals something so that you can substitute the x or the y into the other equation. That gives you an equation with only one variable, and then you can solve that equation and find your solution point. Looking at the system I have written here, this is a perfect example of when this very last way we're going to learn is going to be the easiest way to go about it. So looking at this system, if we were to try to solve this the first way we learned with graphing, right now neither of these equations are ready to graph. So we would have to solve both equations for y. Then you would have to find some graph paper, graph both those lines. You could solve it that way, but it's not the easiest way. The second way, substitution. Neither of these equations say x equals or y equals. So we would have to move something around to get x or y by itself so that we could use substitution. You could do that, but again, not the easiest way. This system here is a perfect example of when we want to use our last way to solve, which is solving by elimination. Now, before we look at this system of equations, I wanted to show you two like nice friendly equations with numbers. So something maybe like 1 plus 2 equals 3. You can pick whichever equations you want. I'm going to write maybe 3 plus 3 equals 6. Something fun you can do with equations like these is you can add equations together to get a new equation. So 1 plus 3 is 4, 2 plus 3 is 5, and 3 plus 6 is 9. And here I've got a new equation, 4 plus 5, which is true. 4 plus 5 equals 9. You could do that with any equations you want. You could do it with lots of equations if you want. But I do this to show you that you can add two equations together and get a new equation. The reason this works is because we're just saying everything on this side is equal to everything. My hands are covering it up. Everything on the other side. Now, the reason I show you that, it's a neat little trick you can do in math, but it helps us with this last method, solving by elimination. The goal of solving by elimination is to add the equations in a way that either x eliminates or y eliminates. Looking at this system here, if I were to go ahead and add these equations together, combine all our like terms, notice this very first column here, x minus x is 0. It's nothing. It cancels, or in this case, I'm going to say it eliminates, hence the name elimination. The other two columns, we've got y plus 2y would give us 3y, and 5 plus 4 gives us 9. Now, what we just did is super helpful. By eliminating one of the variables, we're left with an equation that only has one variable in it. You might have just like automatically did it. What could we do with this right here? We can solve. We go in, divide both sides by 3, and we get y equals 3. By doing that, by eliminating one of our variables, we were able to solve for the other one. We were able to solve for y. Now, using everything you've learned about systems at this point, we know our answers to systems of equations are going to look like a point. Just like always, we're going to have an x and a y. We figured out what y is. You might know how to answer this next part too. We've got y. What do you think we're going to do to find x? The same thing we were doing for substitution. Once you've got one variable, you can substitute it into an equation to find the other one. We've got two equations. Doesn't matter which one you use. I always like to choose the one that looks easier to me, which would be this first one. So if x plus y equals 5, y is 3. So x plus 3 equals 5, which means x must be 2. And ta-da! That is elimination. Just like always, if you wanted to check The check would be you substituting this point into both equations, making sure both of them give you something that's true. The first one, if you check, would say 2 plus 3 equals 5. That's pretty easy to check. 2 plus 3 is 5. The second one would say negative x, so negative 2 plus 2 times 3 equals 4. So negative 2 plus 6 equals 4. Ooh, I'm almost out of room. Negative 2 plus 6 is 4. So we get 4 equals 4, so that one's true too. This is always an optional step, but if you're at home, you're struggling to figure out if you're doing it right, just a reminder, you have a way to check all of these. Now this system was easier to solve with elimination because all I had to do is add these and they eliminated. You might be at home asking, well, wait, like, is that always going to happen? And the answer is no, of course not. So I'm going to choose one other example. Let's look at, I'm looking at example number 6 in the notes if you've got the notes in front of you. But the question says 16x minus 10y equals 10 and negative 8x minus 6y equals 6. So again, looking at this system, we're not going to solve it by graphing. I didn't give you a graph in the notes for one reason. Another, it would take a lot of steps to get to be able to graph them. I'm not going to use substitution because we don't know what x equals or y equals. So that's, when it looks like this, that's a big sign. Elimination is going to be the easiest way to do it. When you've got x, y equals a number. Looking at this system, if I were to try to do it like I did that last problem, if I just went right in and said, okay, let's add them together. Let's combine our like terms. Are x's here going to eliminate? Well, no. 16 minus 8, that's going to give me 8x. Are y, are they going to eliminate? No. Negative 10 minus 6 gives us negative 16. That's not eliminating. We don't need the numbers to eliminate. So right now, nothing's going to eliminate yet. That is okay. It just means we're going to need to do something first to make them eliminate. Now, when you think about, in that last problem, what it looks like for something to eliminate, something like, I'll change this a little bit, something like 16x and a minus 16x. That would eliminate, right? You need the number to be the same, and you need the signs to be different. If that is not already the case with the system you're given, you can change the equation to look like that using multiplication. Side note, kind of like I did at the beginning, if you've got an equation, you can always multiply an equation by a number to get a new, also true equation. So if you were to pick a number like 3, 3 times 1, 3 times 2, 3 times 3, and you get an equation that's also true. So the idea of being able to multiply an entire equation to get a new also true equation is what we're going to use for this problem here. Looking at our variables, we want to see if we can multiply one equation so that we get something that would eliminate, which remember means the numbers would need to be the same and the signs would need to be opposite. Pause the video here, see if you can figure out what we're going to do. It's a bit tricky if it's your first time. What I usually do is multiplying makes numbers larger, so I'm going to look at the smaller number and see, can I multiply it by something to get the larger number? So looking at our y's, if I look at my smaller number, 6, I can't multiply 6 by anything to get 10, right? 6 times 1 is 6, 6 times 2 is 12. It's not going to give me 10. However, with your x's, you can multiply 8 by something to get 16. 8 times 2. 8 times 2 would give you 16. That tells us I want to start this problem by multiplying the entire equation. Kind of goes back to whatever you do on one side, you do on the other. I want to multiply the entire equation by 2. By doing that, that is going to give me 16 here to go with my 16 here. Now sometimes, depending on the signs of the original numbers, you might need to multiply by a negative. Remember, we said we want those signs to be opposite. We need a positive and a negative so that they eliminate. Right now, this one is positive, and if I were to multiply this, it would give me negative. That's exactly what I want. If this negative sign hadn't been here, I wouldn't have wanted a positive 16 and a positive 16, so I would have needed to multiply by a negative 2 to have positive 16 and negative 16. However, that wasn't our problem, so I'll go back to the original one. When we go to multiply our equation, like I said earlier, you're multiplying everything in the equation. So my first equation is going to stay the same. I'm just going to copy it here. But our second equation is going to say negative 16x minus 12y, don't forget about the 6 here, equals 12. Once we do that, now it looks like the other problems you've done. If I went to combine my two equations together, right here, just like we wanted, those would eliminate. Here, the negative 10y minus the 12y would give you negative 22y. And then the 10 plus the 12 gives you your 22. One last step to solve. You can divide by negative 22, and you get your y equals negative 1. Done, right? Wrong! There was a homework question on this in an earlier set of notes. Once you've got y, you're not done. You still need to find the solution point, the entire solution point. So remember, we need an x and a y. We figured out y is negative 1. Go ahead, pause this video now, see if you can figure out what x is. While you're doing that, I'm going to make myself room. All right, welcome back. So you tried finding what y is. I went back to my two original equations. We had that larger, like after multiplying equation, the equation with larger numbers. You could have also used that equation too. Like I said, always like to use the easier looking equation. I don't know if either of these look easier. I'm gonna go with the second one though. So we've got negative 8x minus 6 times negative 1 equals 6. Negative 8x plus 6 equals 6. Subtracting 6 on both sides, so negative 8x equals 0. That's okay. Oop, you got a glare. I'm sorry. I don't know how to. Well, I'm not going to do that the whole time. When we go to finish solving, 0 divided by negative 8 gives you 0. So our final answer would be 0, negative 1. Hopefully this helps a little bit with elimination. There is a part 2 to these notes with 2 last scenarios that you could see with elimination. Hopefully by the end of this week you're in love with elimination as much as I am, because I really do think these are fun. There's just something about multiplying equations to me that's fun. Don't forget, if you're struggling with this, if you have any questions, please reach out to me. I miss hearing all your voices and seeing your faces, so we are here to help. We're always here to help. With that, I hope you have a wonderful day, and goodbye.